Hello, everyone, and welcome to Operations on Radicals Lesson 1. Congratulations on getting through your first unit. We're going to continue our second unit with radicals, which is awesome because you are hopefully now familiar with them, and we're going to start looking at doing some operations on them. So in Lesson 1, we are going to start with adding and subtracting radicals. So they start with this really fun and awesome activity of trying to figure out which one of these equations is actually correct. And from that, you're supposed to come up with some rules for adding and subtracting radicals. I'm going to skip over that. I'm going to tell you some of the rules. So the rule is basically that radicals can be added or subtracted if they have the same radicand and the same index. So they need to have the same radicand and the same index. So for example, if we had 3 root 5 plus 4 root 5, well, you can see that they're both a square root, so they have the same index. They're both root 5, so the radicand is 5. So now we can say, well, if we have 3 root 5s and 4 root 5s and we add them together, we should have 7 root 5s. And same with subtracting. If you had 4 cube root of 3 minus 3 cube root of 3, you should only just have 1 cube root of 3, and you don't have to write that 1 there. Does that make sense? So if they weren't the same radicand or they weren't the same root, then you can't do this. So let's look at a couple more examples here, some longer ones. So we have in example CI here, we have 8 root 7, subtract 3 root 7 plus 15 root 7. So they're all square roots, and they all are square root of 7. So now basically we're just doing 8 minus 3 plus 15. So 8 minus 3 is 5, plus 15 is 20. So now we can say we have 20 root 7. 20 square root of 7. Awesome. The next one, 18 multiplied by the 5th root of 10 plus 12 multiplied by the 5th root of 10 minus 7 multiplied by the 5th root of 10. So you can see we have the same index and the same radicand. So they're all like radicals. And so now we just have 18 plus 12 minus 7. 18 plus 12 is 30. Subtract 7 is 23 5th root of 10. And the last one is a subtraction, 5 square root of x minus 4 square root of x. So if you have 5 square roots of x and I take 4 square roots of x away from you, you are just left with 1 square root of x. But we don't normally write that 1, so we would just say the square root. You have square root x. You assume that there's a 1 there. The next one is a really cool investigation where it says, does this equal each other and does this equal each other? Yes, they do. Does this appear to contradict the rule that you wrote? Yes, it does, because you can see that we have different radicands, but we do have the ability to change the number under the root sign. And so sometimes you have to do that in order to simplify. So I will show you a couple of examples. So it says here, complete the following by writing each radical in simplest mixed form. And then you can add or subtract. So you can see here we have the square root of 2 plus the square root of 8. Definitely we don't have the same radicand. One's a 2 and one's an 8, but we can change that square root of 8 into 2 times 4, or let's do 4 times 2 into 4 times 2. And what we can do from there is first zoom this in so that I don't have to write so small. We now have the square root of 2 plus square root of 4 times the square root of 2. And we can simplify that even further. Square root of 2 plus square root of 4 is 2. So now I have the square root of 2 plus 2 root 2. So now you can see I've converted that. So we have the same radicand and they're both square roots. So now I have square root of 2 plus the 2 times the square root of 2 means that I have 3 root 2. And that's the answer. So it's just about converting into the simplest mixed form. So you can see here that we have 5 multiplied by square root of 12 plus 6 multiplied by the square root of 48. So you can see they're different radicands. So we want to switch those. So what you can do is take, for the first one, you can write it in simplest form by saying, well, 5 is multiplied by the square root of 12 can be written as the square root of 4 multiplied by the square root of 3. And then 48 can be written as the square root of 16 multiplied by the square root of 3. So a good strategy is to deal with the simplest one first. So 12, it was a little bit easier to see that it split into square root 4 and square root 3. And what this told me was, okay, well, square root 4 is going to simplify. So now it looks like I'm trying to get two terms that have the radical of square root of 3. So now when I'm dealing with my 48, I can say, well, I want to get the square root of something multiplied by 3. So now I can, in my calculator, go 48 divide by 3, and that is equal to 16. So now I can switch that to 16 times 3, just to ensure that I have square root 3 in the first term. I don't know why that keeps deleting. And square root 3 in the second term. So now I can go one step further and say square root of 4 is 2. And the square root of 16 is 4. 5 times 2 is 10. 6 times 4 is 24. If I have 10 root 3's and 24 root 3's and I add them together, I have 34 root 3's. Sometimes it can be a little bit tricky trying to simplify these and have them match. But again, try to do it with the smallest one first. Find which radical is going to be your like radical, and then do the same thing for the larger one. So it says here, this is kind of the rule here. In order to add and subtract radicals, they must be able to be expressed as like radicals. So that means radicals with the same radicand and the same index. I guess I should just highlight that whole thing. It's kind of annoying when I've scribbled over it with a highlighter. All right, so let's get some more practice in. The square root of 80, subtract the square root of 20. So again, sometimes these are a little bit tricky to start with. So if it was me, I would start by trying to simplify the square root of 20. And I know that 20 can be written as the square root of 4 times the square root of 5. So now I think that's the simplest it can go. So the reason I did that was because now I'm looking to convert this square root of 80 into something that has a square root 5 in it so that we can subtract them. So in my calculator, I can say, I can go 80 divided by 5, and that gives me 16, which is perfect because 16 is a perfect square. So now I can split that 80 into the root 16 multiplied by root 5. Root 16 is going to be 4. And now I have 4 root 5 minus 2 root 5. So it's a bit of a weird process, but it does help if you don't see it right away that they both can be written as a root 5. So now I have 4 root 5 minus 2 root 5, and that equals 2 root 5. Cube roots. So this is where things get a little bit interesting, a little bit tricky here. So this is why it's important to remember your perfect cubes, right? So I'll write them down on the side here. Our perfect cubes are 1 and 8 and 27 and 64, 125. So maybe we should say that this is equal to 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, and then 216 is 6 cubed, 343 is 7 cubed, 512 is 8 cubed, 729, not 79, 729 is 9 cubed, and obviously 1000 is 10 cubed. So now that we have that, it can be a little bit easier because we're trying to break these down according to nice and easy cubed roots. So again, I'm going to start with the smallest one. It's easier for my brain to do that. So I'm looking for a number here that is a factor of 80. And it looks like 8 works really well because I know 8 times 10 is 80. So I can say this is the cubed root of 8 times the cubed root of 10. And it looks like 10 goes really nicely into 270 because now I can split that into the cube root of 27 multiplied by the cube root of 10. And 27 is one of our perfect cubed, so that's fantastic. The cube root of 8 is 2, so that is the 2 times the cube root of 10 plus the cube root of 27 is 3, cube root of 10. 2 cube root 10 plus 3 cube root 10 is equal to 5 cube root of 10. Awesome. The cube roots are a little bit trickier than the square roots, but if you have this written down right here, it's a lot nicer. Okay, we have 7 root 27 minus 3 root 75 plus 2 root 147. So the easiest one to deal with is the smallest one, I find. So I can split that into 7. 27, I'm looking to write it as the square root of 2 numbers, where one of them is a perfect square. And the reason I like 27 is because I know that it's 9 times 3. So I can write 7 root 9 times root 3. And that means I'm trying to find all of the remaining roots to have a root 3 in them. So 75 divided by 3 is 25, which is a nice one. So I can write that as root 25 root 3. And the last term, if I divide by 3, go into my calculator, I don't see it right away. So I go in my calculator and I go 147 divided by 3, and I get 49. So now I can rewrite that one as 2 root 49 root 3. That's not a very good 49. There we go. And I can simplify all of this because I have root 9 is 3, root 25 is 5, and root 49 is 7. And you can see now that each term has root 3, square root 3, and there's no other root signs or square roots or anything. So again, I just simplify one more step. 7 times 3 is 21, square root 3. 3 times 5 is 15, square root 3. And 2 times 7 is 14, square root 3. So now I just have to do 21 minus 15, which is 6, plus 14, which is 20. So now I have 20 square root 3, and that's my final answer. Whew, these are long, but not too bad. The more you do, the better you're going to feel. You're going to be more confident with them. Okay. Let's look at this one. So I'm just going to tell you right now that you might not be able to get all the terms to have the same or like radicals, and that's okay. You just want to simplify them to the best of your ability, or to the most simple you can get. So now we're dealing with square roots, which is awesome. 50 is always a good one I like, because I know 50 can be split into 25 and 2. That's the most simple way I can do that one. 48 can be split into root 16 and root 3. And I don't think I can go any simpler than that. So you can see already that we have two different radicals there, where we're going to end up with a root 3 and a root 2, and that's totally okay. Root 8 can be written as root 4 over root 2, and I'm hoping that I can get this one either into a root 2 or a root 3, because I've got both. 108 can be written as, well, 108 divided by 2 gives me 54. That doesn't help. 108 divided by 3 is 36. That's actually a good one, because 36 is a perfect square. So I can write this one as root 36 root 3. So let's rewrite that. We've got -5 root 36 root 3 plus 3/4 root 4 root 2 minus 5/4 root 16 root 3 plus 1/2 root 25 root 2. And then we can simplify that, because I know 36 is, don't drop this negative sign either, by the way, that happens. Root 36 is 6. Root 4 is 2. Root 16 is 4. Oh, I forgot that root sign. Root 25 is 5. And I can simplify even further now. -5 times 6 is -30. Root 3. 3 over 4 multiplied by 2 is going to be 6 over 4, which can be reduced to 3/2. So if you want, so I did it as 3 over 4 multiplied by 2, and then I did that little thing where here in my head where I went, well, 2 over 4 is just reduces to 1 over 2, right? So that goes away. It's actually 1 over 2, which is 3 over 2, if I include that 3. Root 2, and then 5 over 4 multiplied by 4. 4 over 4 cancels, and I'm just left with 5 root 3. And then I also have 5/2 root 2. So we just have to combine the like radicals now. I have -30 square root of 3 and -5 square root of 3. So that's going to be -35 square root of 3. And now I have positive 3/2 root 2, and then positive 5 over 2 root 2. So if I'm adding those together, I have 8 over 2. So 3/2 plus 5/2 is 8 over 2. And that reduces to 4, right? 8 over 2 is 4. So I can say plus 4 root 2. And that is as simple as that gets. Or you can flip-flop it if you want and say 4 over 2 minus 35 root 3, or 4 root 2 minus 35 root 3. I just flipped the order there. Let's do one more example. It's kind of crazy and long, but we might as well, just while we're here and just for the fun of it. So we have cube roots now, so it's going to be nice to have our cube root list here, and we can refer back to that as often as we need. The first thing I noticed is that the cube root of 64 is just 4. So that first term just turns into, I wonder why it's not letting me write. There we go. That first term, cube root of 64 over 8 is just going to be 4 over 8. Maybe I'll just, I think I can just, oh, there we go. I'll write it over here so we have more room. The first term is just going to be 4 over 8 because this is just 4. The next one is 375, and I'm trying to find a number that's a nice perfect cube. This one's nice because 375, it's easy to see that it's going to be the cube root of 125 multiplied by the cube root of 3. So let's do that. Plus 2 cube root of 125 multiplied by the cube root of 3. 54. 54 is a weird one. Let's look at our cube root chart here. Maybe 27 times 2 is 54. So unfortunately, that doesn't give us the same base, but I think that's as simple as we can write it. So we can write this 2 over 3 cube root of 27 multiplied by cube root of 2. And then cube root of 24. So we're looking for a number less than 24. It looks like our options are only 8 and 1, but that's perfect because we can use 8. So the cube root of 24 can be split into the cube root of 8, and it's 8 times 3. That gets us to 24. So now we can just simplify. We have 4 over 8 can reduce to 1/2. 2 multiplied by the cube root of 125 is just 5. And we still have the cube root of 3. We have 2 over 3. The cube root of 27 is just 3. And we still have the cube root of 2. I didn't write that down. There we go. And then we have 5 over 3. And the cube root of 8 is 2 multiplied by 3. So it's a bit messy right now, but we can simplify even further. 1/2 plus 2 times 5 is 10 root 3 minus 2 over 3 times 3. Those 3's cancel, and I have 2, 3 root 2 minus 5 over thirds multiplied by, oh, I totally wrote that as 5 over 3, but it's 5 over 2. Easy to make a mistake. This is a lot easier. 5 over 2 multiplied by 2. Those 2's cancel, and I'm left with 5, 3 root 3. So now I just want to combine like terms. It looks like I only have, or like radicals, it looks like the only like radical I have is positive 10 cube root 3 and negative 5 cube root 3. So I can write that as, now our answer is going to be 1/2. Plus 10 minus 5 is going to give us positive 5, 3 root 3, minus 2 square, or that's a cubed root, sorry, cubed root of 2. And that's as simple as we go. Bit of a long process, but they're kind of fun and satisfying when you get to the end of it all. Sorry for the long video. I hope you enjoyed it. Don't forget to like and subscribe, unless you're watching on Google Classroom. Then I don't really know how you do that. But these are on YouTube just for fun. Thanks for watching, and I'll see you guys tomorrow.